everyone. So today we are going to learn about the topic significant figures, which is not only important in doing scientific work or studying physics, but in any field like doing chemistry, doing engineering, while doing medical physics, anywhere. You must know the importance of significant figures. So I, Dr. Nandini, will be teaching you about significant figures today and how to know how many significant figures are there in the in a numerical statement, or if you're looking at a problem and how to figure out and how many figures you have to include to make the answer to be very accurate and precise at the same time. Let's start. So every measurement has units. We know that there is two standard ways of representing the units. Like either we can do with the MKS system or CGS system. But here, let's see. Give me a moment, guys. Okay, so we know that MKS system is there, where M means meter, K means kilogram, S means seconds. Similarly, we have CGS, centimeter, grams, and seconds way of measuring the units. For measuring the units, we need to follow some parameters also, and there is some uncertainty while noting down those values. So we have to understand that thing. So basically, two terms are there: accuracy and precision in measurements. Accuracy is how accurate or how correct your answer is. Precision is how close is your observation to the actual value. So that is your precision. Okay. So good accuracy, good precision. See, all the arrows are lying at the center, very close to each other. That is precision, closeness to the observed value. Accuracy, how accurate, how much it has hit to the center of the board. That is the accuracy. Now again, if you see this diagram, the poor accuracy, it's not hitting at the center but very far away from the center. But if you see the arrow 1, 2, and 3, all are hitting around the same similar point and very close to each other. This means they are following a good precision. So now you could make up the difference between accuracy and precision. Accuracy is how accurate or how correct the reading is. Precision is how close the values are coming out to be. Now, so accuracy is how close a measurement is to the accepted value. And then comes precision, how close a series of measurements are to one another, or how far out a measurement is taken. That is your precision. Again, poor accuracy, poor precision. None of them are coming close to each other, and all are lying away from the center target. Now, what exactly are significant figures? They are used to indicate the precision of a measured number or to express the precision of a calculation with measured numbers. So, how close the value is to the actual one. See. So we are just trying to make out a sense in that. In any measurement, the digits farthest to the right is considered to be estimated. Like we are rounding it off. Like so we know that whenever it is more than 1.5, it rounds off to 2.0, and whenever it is less than 1.5, it rounds off to 1. So we can say that where can we actually use the significant figures? So if we talk about the mathematician, he will always say the value is 21.70. What exactly the values are coming, like you use calculators, so they will just give that value. And also for 21.700, that means the same for a math person. But if you talk about the scientist, no, the things have changing. If we talk about this number, I will rather say it has 4 significant figures, but it has 5 significant figures. We are actually interested in 5 digits. We are actually interested in 4 digits as per the physics person or a scientist, we can say. So, but to a scientist, they are not the same. But I told you, like it's not same for me, so not same for you who are taking this lecture right now, watching this video. So it means the measurement is accurate to within 1,000th of a centimeter. We know that 700 is it? It is 700th DTH, right? So it is 1 It's accurate within 1000 of a centimeter, so we have to look for this. How do I know how many significant figures? Actually, how to know that? So any non-zero integer is always significant. Like 3, 4, 5, 6 has 4 significant figures. Okay, and if we see the other one, let's see, 7, it means only one significant figure, right? Because only one integer is there, non-zero integer. Again, one non-zero integer, one non-zero, one non-zero, one non-zero, one non-zero. So we can say everyone has one significant figure. This is so different. See, everything is having a different values, but again the significant numbers are only one, because I told you significant number is not about accuracy, it's about the precision. So how to do that? So there are basically three classes of zeros. Leading zeros, which are coming before, that precede all the non-zero digits, these do not count as significant figures. This means it has only two significant figures. So 0, which are coming prior to the non-zero number, they are always non-significant in nature. They do not count. Then next is captive or sandwich zeros, which are coming in between non-zero digits. They are always and always significant figures. So if they are in close by, if you're having two good friends, you will be also becoming good. But if you're alone in the prior, like this is just a common example, left alone in the island, it's no, it makes no sense actually. So it's simply, I'm like, I just want to make a sense of it, that any zero which is coming or sandwiched between two non-zero integers, it is always significant. Hence it has 1, 2, 3, 4 significant figures. But when we were looking at the early example, if I have like 0.07, again only one significant number, because it is not sandwiched, it is not coming in between the two integer numbers, or two non-zero integer numbers. That's right. Okay, now how do I know how many significant figures? Again, the Seek rule says that trailing zeros are zeros at the right end of the number. They are significant only if number contains a decimal point. So if I want to mention that 9000, it is not significant. Only one significant number is there. Rest zeros are non-significant. But if I put a zero here, I put a decimal point here, all the numbers will become significant. For example, 9.300 has 4 significant figures. Again, 150 has only 2 significant figures, right? So I know this will take some time to absorb these rules, but yes, that's simple, and with practice we will get to know. And we will have some more questions in the coming up video, okay? So I will make you do certain questions on that. How do I know? Again, 300 contains 3 significant figures. Why? Please write in the comment section. But yes, I would like to make a comment on this. 300, and there comes a decimal dot. So please look at the number carefully in the questions or problem statements. How many significant figures are there? Because you have to follow that rule while solving your numericals, else your answer will never come up to be correct. Significant figure is so important while doing all sort of questions in any science topic. Okay, so decimal made the 2 zeros significant in nature. If number would have been written as 300 without a decimal point, then only one significant number, right? Now let's go with it. I would rather expect to comment your answer first for all these parts, and then look up further. Okay, so I'm waiting. I'm giving you some time to comment about this. Okay, so let's verify whether your answers are right. 4 for 3401, because it is sandwiched between two non-zero integers. Then 2 because it is not sandwiched between non-zero integers. Then 5 because it has a decimal point here. Again 3, decimal point. Now it has zeros ahead of it but not sandwiched, so only 3 significant figures. Now zeros which are coming in between the non-zero, they are significant, rest will be non-significant. So how many? 6. 1, 2, 3, 4, 5 and 6, right? So that's about significant figures. Again, some more questions for you so you can practice after this. Okay, so I'm posting the answers for you here. Same rule, similar. Okay. Now let's come to a other segment of significant figures. How to know about exponential notation, the scientific notation. If your value is expressed in proper exponential notation, all of the figures in the pre-exponential value prior to times 10 are significant in nature. For example, 7.143 times 10 to power negative 3 grams. It contains 4 significant figures, right? And all these things, these zeros or coming in negative or positive power, they will be non-significant in nature. Now, how to do calculations? I have been telling about this, that this will play a role in numerical power, problem statement while solving for calculations and everything. So, how to go about that? Actually, what we have to do, the answer can have no more places after the decimal than the least of the measured number. So, whatever, so you have to look up for every number in the question, like if 4.3 is meter is their distance and 2.34 meter per second velocity is there, so you will say 4.3 has 2 significant figure, 2.34 has 3 significant figure. You have to go with the least number. If you're if one more thing is there, 1 second time is also given in the question, this means only one significant figure. You have to follow this rule while stating your answer. Okay, so you will be going up with the least number of significant numbers, and that you have to follow while giving you answers. For example, we have this question 2.45 plus 1.2, again 2 significant numbers. So I would have to follow that while giving my answer. Ultimately, when you add up, it's simple. We know that from primary classes, it adds up to 3.65 centimeter. But once you round it off, it will come out to only 3.7 centimeter. Why we are rounding off? The only answer is we have to follow the least rule. We have to keep the significant figures to the least number which is given in the question. This is 2. This was having 3, but I would rather follow giving the answer is 2 significant figures, right? Now, this also makes sense because it has only one significant figure. My answer will be also in one significant figure. And we know the rule of rounding off, right? If whenever the number next to decimal is less than 5, you make it as 0, right? It's like you round up to the lower value, like if it's 5, it's more than 5 equal to 5, it will come up to a 6 plus 1 will be 7. But if it would have been 3.64, your rounding off would have been gone to 3.6 only, right? Because this is less than 5. Similarly, 9.4 less than 5, so it will be 9.9 centimeter. If it would have been 9.5 or 9.6, it would have gone to 10 centimeter. Again, it makes sense. Yes, 10 has only one significant number, right? Similarly, while you have a problem for multiplication and division, again the result cannot have no more significant figures than the least reliable measurement. Again, we are following the least rule. For example, we have this question 1, 2, 3, 4 and 1, 2, 3. I have to follow with the 3 because 3 is the lowest number, so I will make round it off to 3 numbers only. Again, this you have to try, but I would like to tell you, you have to round it off to 2 significant numbers. Why? 2 here and 3 significant figures here. So round it off to 2 significant figures, whatever the answer comes. So rules for rounding: in a series of calculation, carry the extra digits to the final result and then round it off. If digit is to be removed less than 5, the preceding digit stays the same. For example, 2.34 rounds off to 2.3. We know that this is simple rounding off rule. If digit to be removed is equal or greater than 5, then preceding digit is increased by 1. For example, 2.36. 6 is more than 5, so the other digit will be added up with 1, so it's going to 2.4. So let's take a quiz. So I'm giving you some time. The term that is related to the reproducibility or repeatability of a measurement is, think over it, and then I will show you the answer. Precision, because I showed you a diagram in the initial slide, right? We have a board and how close the values are, that is precision, right? Repeatability, every time going to similar target. Reproducibility, that is precision, okay? And that is about significant figures. The number of significant figures in the mass measured as this will be how many? These are not sandwiched. I don't think you need options for this, but still, okay. So it will be only. See, this 0 is coming after decimal. So let's see. 5. Right? Got it? Because this 0 is after decimal, it will be counted. And rest, this will be counted after decimal. But these are non-sandwiched ones, so we cannot count it. Okay? Again, let's do this part. I need the answer from you this time. Okay. And I will always suggest you to post your answers in the chat and in the comment section, and whatever your doubts are also post in the comment section. I will be looking up all the things regularly. So let's see. 5. Okay, right? Makes sense? Because it's after decimal points and these are not counted, right? And how many significant figures? Simple. Okay, and let us do it quickly. Yes, 4. Thank you everyone for watching this video, and we will be coming up with the next lesson soon. Thank you. Bye bye. Have a great day. If you have any doubts, any questions, post in the comment section. I will check out and reply over there. Thank you. Bye bye.